Good afternoon, everyone, and welcome to BSides Las Vegas Breaking Ground track. This talk is given by Andy Grant, and it's unpacking macOS installer packages. But before we get started, we want to thank our sponsors, including Valimail. That's how you say it. It's Valimail, not Valley Mail. I got confirmation on that. And Amazon, BlackBerry, NSA, and Microsoft, along with our volunteers who help make this go. This track and talk is being recorded and streamed, so we ask that you put your cell phones away and on silent, and we'll let Andy get started. Thanks.
Thank you. Yeah, so I'm going to be talking about packages, specifically Apple macOS installer packages and some security flaws on them. So first, a little bit about me. I've been doing offensive security professionally for 11 years. I've been doing security as a hobby since my early days, 20 plus years ago. Started out self-taught, just playing with computers, trying to figure out what was going on. Led me to pursuing a computer science degree at Stanford. Right out of undergraduate, joined ISEC Partners, a security consulting firm. Got to do some penetration testing. Then that got acquired by NCC Group. I stuck around and I'm still with NCC Group. My professional career has been very application security focused, ranging from web apps, mobile apps, native apps, and things that get installed. Over that time, I did 5 years as a security consultant, doing all different manners of the ranks there. Then I decided I'd try my hand at management, become a vice president, manage a team of 30 people. And for those 5 years, I spent most of my time trying to figure out how I could make an excuse for me to be back on the projects that my team was supposed to be delivering. So I gave up management, and I'm back doing the technical work and what I love. But this is a quick version about me. I'm better known amongst the world by my hacker alias, Dana Vollmer's husband. My wife is an Olympian. I get known as a +1 everywhere I go. You can read all about it with a little bit of Googling. And yes, I do find time off to support her and her goals. We're going to talk about why I did this research, how it came about. We're going to look inside the package. We're going to look how do you get inside of it and audit it, and then what can and what have I seen go wrong with these installer packages. So first, why was I doing this? Well, I've got trust issues. I don't like computers just doing things for me. I like to understand what they're doing. I don't trust the software that comes with them or the packages or the file formats that come. I like to dig into them. Started with Word documents. They're a zip file, open them up, dig into them. So you start to see these pop-ups now and then with when you're installing something. It's going to run a program to determine if you're compatible. But that's all you get to know. What is it running? I wanted to understand that. Luckily for me, part of my job is understanding what goes on. Sometimes a client gives us an application that they want us to install, look at what's going on, so we do so. Then the application doesn't work. The network it relies on is down, or it's in a debug mode that is incompatible with our systems and whatnot. So we try to get creative. Sometimes all you have is the installation process to look at and provide the client value, so you figure out ways to do that. So now we're going to look at the package, get into the technical bits here. So these are full technical name, Mac OS X installer flat packages. They have the pkg extension. They came about around 2007 with OS X 10.5. There's little to no official documentation provided by Apple on what's inside these. They have tools for building these. They used to have better tools for building these and actual UI tools. Now it's sort of undocumented outside of man files, command line tools. There are some good unofficial documentation out there, but it's fairly incomplete. There's parts of the package that are completely undocumented across these, but you can find out bits and pieces and piece things together by poking around or by opening them up yourself. It's a flat package. It's the single file. Specifically, it's an extensible archive, or ZAR. Before the flat packages came about, you had bundle packages that were used. These are very similar to the .app application bundles you'll find, which really are just a folder that Apple, that OS X knows how to open and look at, and you used to be able to just browse inside the folder, look inside, see what was going on before running the installer. Now it became a little bit of an obscure archive type, and it became less obvious of how to look at that. There are some tools provided. Your Apple laptop comes pre-installed with something called Package Util, very handy tool that will allow you to look at packages and edit and modify packages. There's also some third-party tools out there. Suspicious packages is one specifically to look at, sort of what I'm talking about. It shows you the signing certificate, the files that are going to be installed, and does some sort of checks on what may or may not be the norm for an installer. It rarely flags true security issues in my experience, but it does give you something of like, hey, there might be something worth digging inside. Plus it has some extra tabs to look at the files and the scripts that are run by the installer, which we're going to get into those in a bit. So Package Util, this is a snippet from the man page. It's provided by Apple to query and manipulate the installer packages and the receipts. The receipts are the system record of what has gone through the macOS installer and what files it has left behind on your system. That's a very handy thing to poke around with. Here's just a small snapshot of the commands you can use. Looking at the receipt package database, you can look at the packages that have installed, the files by those packages. You can do it in different formats, see what volume of your system, what drive of your system it was installed on, and the target directory those files were placed into. When you do files, it just lists them relative to the package, not where they are in your file system. So you have to clobber that together with some of the package info stuff of this was installed to this location, and then you go back to the list of files and you can see where all those files were placed. Then you can also mess with the packages and expand a package and flatten a package, or flatten into a package. But so let's take a look inside. So to unpack it, the easy way, use the provided tool. You just give it the expand command, give it the package, give it a non-existent directory. It'll create that directory, extract the files into it, and you can go about browsing those. But you know, that's the easy way. We're here to be hackers, to not trust the provided tools. So I can go create the directory I want to, change into that directory, and then use the ZAR command to extract the package. I do the create directory and change into directory because ZAR doesn't support an output directory, and so it just clutters the current working directory. So you want to get into a clean working environment before you go through. So inside the package, you'll typically find a distribution file, which is an XML file, a resource directory, which has all manners of different images, licenses, readmes, backgrounds. Then you'll have typically one or more package directories. These directories contain the bill of materials, or the list of all files that are installed, the package info, another XML file, and then payload and scripts, which are further compressed archives that sound really interesting. So let's dig into these files a little bit. For the distribution file, it's XML and it can contain JavaScript. So the XML is defining the title that will be displayed in the installer, the welcome text, the README, the background image, the little logo on there, defines whether you need to do nothing, restart, or shut down your system after the installation is complete. And then it can contain scripts that are triggered by installer checks. So you can define an installer check. The installer check references a JavaScript function that is then defined within script tags within the XML document. It uses a subset of JavaScript called installer.js. Apple does provide documentation on that. Package info, another XML file, easy to read, look at, contains sort of meta information about the package, the installation requirements, how many files are being installed, what's the total number of bytes being installed. It also defines where the files are going to be installed and what permission level those the installer needs to run. It'll also include paths to scripts that need to be run pre-installation and post-installation. You have the bill of materials. This is, like I was saying, the list of all files to be installed, update, or removed from the system. It includes the file permissions, the owner group, and the size and creation time and all that normal file system information for each of the files. The payload, this is where we're getting into more interesting stuff. The payload, the files that are actually going to be installed. This is actually a CPIO archive that is then gzip compressed. This is the archive that contains all of those files called out in the BOM. It is what gets extracted into your file system at the location that package info specifies, the install location. This is just the installation part of the process. It's an extracting of an archive onto your system. There's nothing more fancy than that really goes on as far as the files that get placed on the system. You can also have an optional scripts archive. This is the same as Payload CPIO archive that's been gzip compressed. You have pre and post installation scripts and additional resources. It can really contain anything. It's an archive. You can put whatever you want in it. I've seen README files that were then pulled out and referenced by the distribution instead of being in the resource file. You can see some of the payload files for whatever reason being in here. Anything you want your scripts to be able to directly interact with should be in this archive. The scripts can be Bash, Python, Perl. Those are the most common. But really, the only requirement for it is that it has to be executable and has to have an appropriate shebang. This archive, when the installer is running, is extracted to a random directory, a temporary directory that's not predictable. So it's not really something you can mess with unless you sort of pause the installer, don't click the next buttons, and then look at the run environment and find where that directory is, and then you can go look at what got extracted. Or you can open it up yourself. You already extracted the larger package. Let's look inside this gzip CPIO file. So the long way to do this is you can cat the contents of the archive into gzip to decompress it and pipe that into CPIO saying it's taking input, and it'll dump right into the current working directory all the contents of that archive. But CPIO actually natively automatically recognizes gzip compressed files, and so if you just send the archive directly into it, it'll extract right into the current working directory. However, if you did this through the easy way initially using package util expand, this was all done for you, and instead of the scripts object being inside the directory that was created, being an archive, it is already a folder, and that folder contains the contents of the scripts archive. There is no actual scripts archive if you do the expand command. Payload, same as scripts, skip right to using CPIO. Sometimes the payload contains further packages, and so you recurse through this process, expanding all the packages, looking at opening all the script files, finding everything that you may want to audit or look at for security issues. However, you're blowing up all these files. If it's a big application, you may be worried about your disk space. So you can check out the BOM, which, like I said, lists out everything. Run lsbom. And it will just list out all the files, and then you can look through and see if there's anything you feel like may be worth opening up the package to extract and look at. Unlike with scripts, if you use package util expand, this does not automatically expand payload. You do have to go in and manually extract this if you want to get the files out without running through installer. Okay, so what happens when we double click this package and the installer launches? Well, rough order of execution, things we care about here, what gets executed on the system. It parses the distribution file if it's present. It checks for installation checks, looks to see if there's any scripts to call, calls that JavaScript function defined within distribution, executes through that to that function, can call further functions and whatnot, as long as they're all defined there within the distribution file. Then you click next in the going through your installer, you get to the pre-installation phase. This happens pre-extracting the payload archive onto your file system. If the package info defines the pre-install file, this path is relative to the script archive. It goes in, pulls out that, extracts the scripts, executes the pre-install file, and moves on to extracting the payload. Payload is extracted into the install location as specified in the package info. And then we move into the post-install phase. If there's any post-install scripts defined, it goes through and opens and executes those files. So now we get into the fun bits. What can go wrong here? Well, so the interesting parts, the scripts that get executed and the files that get written to your file system. So with scripts, you got the pre-install, the post-install. They can contain other scripts, like I was saying, that can be called from pre-install, post-install. Look at them, audit them, read the bash scripts, read the Perl Python scripts. It's normal mistakes people will make in those. We'll talk about the specifics in just a bit. Or the payload archive may actually have its own scripts that are easy to audit. I like the scripts. It's a text file. They're easy to look at. So you can find uninstall scripts, various debugging or help scripts that get written with the application. Or you can go look at native applications and those issues, brush up on your reverse engineering and debugging skills. You got the binaries, you got the kernel modules, you got the libraries right there. You can go open those up, look at what's going on from a non-runtime environment instance before it ever gets installed on your system, just placed there within a directory of your choosing. So the types of issues that I was encountering and I'm going to talk about are largely talk to, time of check to time of use, except almost all of these happen without any check. They just go and use, assuming the files are safe and ready. Most of this happens within the temp directory. So they make assumptions that anything I put in temp is safe to read, or safe to write to, or safe to execute. Fun thing about temp is anybody can write to it. It's world writable. Yes, once you write to it, generally your permissions are locked and other people can't write to those, but you have to make sure that you were the first one to write there, hence the talk to. Plus, I've seen people going, just granting 777 file permissions, read, write, execute access to everybody on the system for the files they place around on either in the temp directory or in the application directory or in application support and the libraries. It gets kind of messy. So now we're going to look at real issues and real packages that I've seen in the past 8 months. So we're going to look at a normal user to root privilege escalation, some symbolic link abuses, privilege escalation from any user on the system to the current running user, arbitrary directory deletions, and arbitrary code execution. The first one, here you have a normal user launches this installer. When the installer runs and it doesn't require root privileges, it can go drop this installer util file into the temp directory as the current user, and then it goes and tries to do root privilege actions in the post install. That triggers the installer to say, I need to run it with administrative privileges. You'll see the prompt, enter administrative username and password. And so the catch here is user install util is owned by the current user, but that user may not be the person who had the password to do sudo actions, to do administrative actions on this. Say it's your corporate laptop, you want to install a video conferencing file, you know it has this vulnerability here, and so you ask your IT to go and install this package for you. They're going to type in their username and password for you to allow it to install. But behind the scenes, you're waiting while that file doesn't exist. Do nothing. Once it does exist, delete it, copy your exploit into that location, and then you wait for the post install to go and call it with root privileges. And you, on your local system, the person installing it just escalated up to administrative to root privileges on this laptop. The next issue, symbolic link abuse, is twofold here. In the pre-install, it tries to do some cleanup. It wipes away this NS installation file. And then during the post-installation, earlier in here, it's written some stuff to that file, and it changes the permissions on that to 777, and then it changes the owner to the current user of that. The fun thing here is any user on this system can preemptively create that file so that when this gets removed, you're sitting there waiting for it. So while that file exists, do nothing. Then the pre-install triggers. That file no longer exists. So we move into here. We create our symbolic link to applications, and it's pointing to that file. So the change permissions will follow that symbolic link, and since it's with root privileges, it will change /applications to now be world writable by anybody on the system. And then it will also change the owner of it to the current user installing the file. So this just grants any user, any process on the system the ability to go install anything that they would like in the applications. You could have done that. Since it's not recursive, I didn't choose /etc because then it doesn't make all files there world writable. It's not -r. But I can now go and install different applications in there, which can lead me to compromising other users once they go about executing the applications I've put on there. A regular privilege escalation. This is running as the vulnerability is in the pre-installation. It again tries to do some little cleanup stuff, saying, oh, sometimes I place a 7-zip file if this installer had been run previously. Remove the 7-zip file, go through and unzip the 7-zip package that we brought in with us in our payload and output it into the /dump directory, then go through and execute that file to extract some more stuff into the directory we're going to put the file contents. So any user, any process can attack the installing user on this. Notice nothing's running as root here, so we're not gaining root privileges on this system, but it's very easy. I copy my exploit into the directory before this installer is ever run. This is owned by the attacker, which since this is not root, it can't delete it. It can't overwrite it, but it sure as heck can execute it. And so no check to make sure that the appropriate owner of the 7-zip file was what this installer expected it to be. And so if that file exists, it can't delete it, it can't overwrite it, it still exists there, and it'll happily go through and execute it with the current installing user's privileges. Another one, this happens outside of the installation scripts. Like I said, in Payload, it might have other scripts that get run. At some point during this application's lifestyle, it calls out to a script that got installed through the Payload. It does a little cleanup of stuff, so it was populating this directory with some debugging information, and then it goes through and cleans up when it's done with this script. It does a recursive remove of SDU/star, and remove dir SDU/. So the way symbolic links work on the Apple system is the / it'll follow the symbolic link. So we're not running with root privileges, so our attack has to be, they have to be deleting something that they have permissions to delete. So you pick their home directory, create the symbolic link before the script ever runs with the application. The /star will put a / there, star, which puts us into the victim's directory. It follows through, delete every file in their system directory recursively, forced, no prompt. And then remove directory with the / will actually follow the symbolic link. If you don't have the / here, it tries to remove the symbolic link. The symbolic link is in a directory. It fails out. You put the / there, follows the symbolic link, and now you just blew away their actual home directory as well as all the files in it. And you have a symbolic link left around that points to nothing. Then we get to arbitrary code execution or arbitrary installation on this. So in the package info, this package defines an installation location, meaning that its payload is going to extract all of its contents into the temp directory Razor Synapse. And it's going to do it with root privileges. And so in the post install, it goes into that directory. It looks for all the package files. And then for each package file it finds, it installs that package. This, running it from the command line like this, doesn't pop up the UI, skips all user interaction, and just force installs it with our root privileges. So install location, when you're extracting this payload, it doesn't care if that directory already exists. So you can go ahead and pre-create that directory. It's going to put whatever package files you want in it, and it'll be your package files, and it'll happily go through and find all of them for you. This has been fixed, and so we're going to demo it. We're going to look at this. We're going to go through the whole process I just talked about. We're going to download a package. We're going to open up that package, look at the files inside, check the distribution file for installer checks, go through, find the vulnerability, create our exploit for this, execute that exploit. So here we go. Go download it. It looks like I'm downloading it from their real website, but I actually hijacked this DNS and used a vulnerable package since, like I said, they had fixed this. So we go, create our directory, we extract the file, and now we're inside the distribution file. So we extracted the file, open up the distribution file, and now we're looking for here, okay, is there any installation checks? That's mainly what I was concerned about when looking at these. Nothing really fancy going on in here. Great. We'll go through. We'll go into the package file, look at the files. Now we're going to look at the package info file. Okay, so we have the package info file. We see that install location, that it's running with root. We also can note that after installation, it's going to require us to restart. You can see here when I was saying it has like the number of bytes installed, the number of files that it installs, and the script that runs after the payload is extracted. Great. Let's go look at those. So now we're going to extract the scripts file. First we make our directory so we don't clutter where we're currently working. Extract the scripts. Look at what's in there. And now we're going to open up this is the post install. And we're going to look through the file, the code, looking for anything of interest, go through. Here's our vulnerable bit that we're going to play with. And so now we'll want to go through and create our malicious payload. And to do that, we're going to switch to our attacker, Mallory. And she's going to go through and develop this exploit for us. So first, we have to create the directory we're going to write our script into, because we want to have some script run. Create our script. We're just going to do a simple shell file. We're going to touch a file in the temp directory to prove that we ran. We'll date it. We'll show what user we ran with what privileges. And no exploit is complete without popping calc, so we'll pop calc at the end. Now we make that file executable. If it's not executable, it doesn't work. And then we use package build to create the package that we'll then put into the temporary directory. So here, you can give an identifier. If you don't give an identifier, it automatically creates an identifier for you. But for our purposes right now, this isn't very important. We specify that there's no payload, that there's no files we're installing here, so don't worry about trying to make the payload archive. And then we specify here's the scripts to make the script archive. We just give it the directory, it'll archive up everything in there. Package got created. We're going to create the directory and move our payload into that directory. Great. Now we just wait for somebody to come along and run the installer for us. So Bob is going to be here and install the package, go through. He's not an administrator, so we need Alice to come in and type her password for us. She's going to go run. There's our calc pop. And then we go look and confirm that we ran with root privileges. So that is start to finish, downloading a package, opening up a package, looking at all the different parts of it, seeing a vulnerable part of the scripts, creating a payload that exploits it, and waiting for the installer to take place and go on. So while looking at these installers, I noticed some things that were unexpected. Some I sort of hypothesized myself, some I saw in the packages going on. But so that no payload package that I demonstrated there, it leaves no receipt. Remember I talked about receipts at the very beginning here. So the receipt is the package identifier. You can look up all the package identifiers that have been installed in your system. And then it's also the files that were installed there. If you don't install any files, it doesn't record your package identifier, and it doesn't record any files because you didn't install any. So there's no record of that payload executing. Whereas there is record of that Razor package executing on the system and all of its subparts with their identifiers. Also, for fun, you can pull this out of the pre-installation scripts and put it into the distribution install checks, where you're supposed to be checking system compatibility, and instead execute everything right there. It's basically a one-click install, and we'll take a peek at that. So here we're going to look at the packages on our system. So this is just scrolled off the screen, all the packages that are installed on here. If you scroll up to the top, there's a lot of Apple packages, so you can actually look at what came installed on the system via the installer. So we're going to actually try to look to see, are there any NCC packages installed here? There aren't any. Cool. So now we're going to show that I pre-created a payload directory, and now we're going to build a package with a NCC group identifier, so it'll show up in our list. This is where I say, this is sort of the create payload command. This is our payload's root directory. And then I'm going to say the installation is the temp directory, NCC group, create our package, run the package, go through, install, great. Look at the files there. Things were installed. And then we'll go and look and confirm that there is now a receipt of that we installed on the system. You could also then do package util -- files, give this identifier, and it would list out foo bar as the files that were installed. So now we're going to go through and create a no payload file. And I'm going to do it through the distribution's installation check. So I want to create the CPIO gzipped archive payload and include it in our scripts folder, because I want everything to be able to be contained within the scripts, since I'm not doing a payload file. So now I'm going to go look at the script I have. The script is pretty straightforward. I define an application directory, the same one we were just installing into. I clean it up. I remake the directory. I copy the payload. This is when you're in your scripts, all your paths are relative to the script archive. And so I copy the payload into that directory, and then go into that directory, extract the payload, and then remove the package. The -D here just means create any necessary folders and directories as you go, sort of like -P and make dir. And then I get fancy and I kill the installer, so because we're done. This is all I wanted to do. I wanted to install my payload. I don't need the installer process anymore. Go ahead and kill it. So let's go look at that distribution file. Here's the title that I'm going to have show. Here's a package of reference identifier. And then I say I allow external scripts. That means I can now do system.run and call things in the script archive. And so now I have this installation script, install check, looks for the script definition. That's defined here. It does system.run. Like I said, system.run can only do files that are in resource directory or in the scripts archive. So that's the script we had already looked at. Now we're going to go build our package. when you do a package build, it doesn't actually include a distribution file. That's for product build, but product build expects you then to embed a package in there. Gets all complicated. So I'm going to create a package, a no payload package with that script. I'm going to extract that package, copy my distribution file in there, and then flatten that package back up. So now I created the package so the installer will understand it. I then extracted the information from it, copied my distribution file into there, and then I'm going to say, please go flatten that back up. It'll pull the script archive back into the CPIO archive, and then put the whole package back into XZAR format. Now I'm going to run this payload. That was it. My payload just got installed. We can go back for those that might not have been paying attention. It happens really fast. There it is. The moment I click that, the installation, so that pop-up says you're going to run an installation check. And then it goes, and that installation check was run the pre-install script. And then that script extracts the payload and kills the installer. And that's why it disappears the moment I click that continue button. Everything just got installed. You can go look at that. It's all relative to when I did the find command, it was package / payload / the files in there. Now we're going to go look, and it's still just that first payload. There is no record that I just installed these files on the system. I bypassed the system's record of my installer running, but I still got to do everything I did. Plus, I didn't have to type in an administrative password, and so I skip that step. One click install after the installer is opened up. Super user-friendly, super kind of weird. And so that is that. You can go do a bit more with package installers, and it gets sort of fun when you start to play around. The fantastic people over at Proterian did a 2-part blog post about using installer to bypass application whitelisting on OS X, specifically Google's Santa, which is one of the better known, better used application whitelisting programs. The way it works at the exec V level, and installer, the binary is whitelisted. So it's basically at the binary level. You can't do it at the process level or whatnot. It's things that gets executed. So everything that runs in installer checks, everything that runs in those pre and post installer scripts runs as part of the installer binary, the installer process, which is whitelisted. So you can use this install checks with the kill installer to make a one-click payload that bypasses Google's Santa, the application whitelisting. Fun for red teaming, which is what they talk about, how they used it. Obviously not fun for anything but testing. And that covers macOS installer packages and things you can find with them. I knew everybody was going to have a lot of questions, so I sped through that. So we got like 10 minutes for questions. I saw a hand pop up over here. I believe we have a microphone, unless you feel like you got a booming voice.
Well, let's find out. What about the Audit Demon that runs on macOS X? So I think the Open BSM Audit Demon, would it capture your actions?
The Audit Demon, like Gatekeeper? No. Or, oh. Yeah. I didn't play with Audit D. So some of those actions, if I'm touching places that it's monitoring and stuff, it'll still trigger. But if it doesn't whitelist installer, as installer can do whatever it wants, and that's sort of the flaw that happened with Google Santa, was it's sort of limited in what it can or can't allow and deny, and so it has to allow installer because that's the expected use, and so anything that installer does is approved by the whitelisting. Right.
Yeah, it would allow the process or the exec V without the context of it's doing something.
Right.
Weird. So, yeah, I wonder. Yeah, Audit usually, I think it gets most system calls. So, and they tie into an EDR.
It does. It captures everything.
Okay, yeah. So
But nobody reads it, so.
Yeah. So there's probably some logs that you can go and audit and look at. I don't know, maybe OS Query can have an alert on it or something and be pulled into some central logging.
Thanks.
Yeah. There was also a leapfrog back. Yes.
Hey, thank you very much. How often do you come across packages that don't execute as root? Because that seems to be the default that I see. And then it was weird seeing the sudo in the scripts because they always inherit it.
Yeah, so that was an interesting thing in my auditing. Everything seems to install. If you noticed when I did sort of my demo of this will leave a receipt, and I was just right into the temp directory, it actually required me to enter an administrative password. There is not a way to build just a package that doesn't require root. So I could have gone in, manually edited that package info file, removed the auth from root to none, and then it wouldn't have prompted for that. Or when you do product build and do the proper distribution file, you can set the permissions. But most people just inherit the default. Everybody expects to have to run as an administrator when you install anything. And so even if you don't need the administrative powers when you're installing, like you're installing to the user's local application directory, it still writes it with root privileges. Over here.
Yeah, do you see a lot of this being used in malicious software and red team testing? I mean, how much do you see this in the wild?
So see it in the wild all the time, at least 6 times in 8 months. But as far as like maliciously in the wild, I haven't known malware to do this. It is much more of the red teaming process. The Praetorian blog post talks greatly about why they chose this route. One of the key parts about doing a red team is it has to be within the user's expected norm on the system to fly under the radar. Installing something is very much part of the expected norm. They even went so far as getting a proper Apple developer certificate, and they signed their package. If you had downloaded this and it was unsigned, you would have to go in and click in system directories, install anyways, which is outside the user's norm for most people. And so it's not hard to get that developer certificate. It's not hard to sign it and then just have it emailed around and whatnot. Here, because I built them locally and just ran them locally, I don't get those alerts or concerns. But if they had been tainted through coming down through the browser, they would have been. Well, actually, so building off of that, I have seen the install during the installer checks in the distribution file, that one-click install in the wild, but not maliciously. It was for users' experience. It just has the side effect of bypassing the receipt, but it is that one-click install. You're instantaneously got your application installed and everything.
But this would be really good for like a supply chain attack.
Right, yeah.
I have a quick comment. Jaron Bradley at RSA this year used the installers to bypass SIP by predicting those temp directories that they create that you mentioned.
Oh, okay, yeah, those temp directories, I didn't want to go through the effort of seeing if they were predictable, but that's awesome that he was able to predict them, because it is one of those like /temps, temp dot blah 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 garbage seeming stuff, and so. Oh, nice. Yeah, because I would imagine if you could sort of hijack the location that's going to be, you can do some of these symlink attacks and same things.
Here you go.
Up front.
Hi. With relation to the privilege escalation that you showed, isn't this kind of like the, what do you call it, the security off trampoline all over again?
Yeah, it is. It is sort of just hijacking, the user's already authed, or basically throwing up the prompt. Particularly the escalation to root. I don't know if you're talking about up to root or the other one.
Up to root, yeah.
Yeah, this one, I could also create my own installer that will give me root privileges and then go, hey, IT admin, I'm installing, video conferencing software. Can you come type in your password? It works better if I just say, here's my laptop. Could you install the video conferencing software? Because I know I could, in the background, be doing this. But yeah, it is very similar to those types of attacks.
All right, thank you.
During your exploration of the package format and the specification, did you find any built-in mechanisms for developers to use update mechanisms? Was that something they had to hand gen themselves? If so, is that some form or vector for like persistence or privilege escalation? This way you don't have to potentially know beforehand whether or not the package would be installed or be used within the organization?
Yeah, you can, in the package info and in the distribution, you can specify whether this is an update. And then a lot of the time, the way I saw developers doing this was in the pre-install, they would check, does this file pre-exist, and then check the version of it and whatnot. But you can also include that in the package info that this is this version. If this version exists, run these commands. Otherwise, run these commands. And then the BOM, it's not just the files that are being written. It also can specify this is being updated or these files are being removed. So the package and installer flow does support the update, but I do see more of the custom code written in the installer scripts of, hey, this exists, blow away the directory, recreate it, copy the new files over, sort of their own self-cleanup.
Do you think this stuff might be going away with Catalina, or do you see this staying around because it's really the only way to install stuff?
I'm surprised how often I still saw this package install for files that were just writing to the applications directory, because everybody has migrated towards the DMG volume, drag and drop to the shortcut that's already in there. And so why go through this whole installation flow? I mean, that bypasses the whole receipt system also. But there still isn't a good flow outside of this for getting things into application support, kernel modules, libraries. And so that's why you see Razer was a great example here, is because they're going through and installing mouse drivers on your system. You don't want those in /applications. You need those tucked away in the application support directories. And so installer is really the only way right now to do that. It will be interesting as SIP migrates deeper into rootless, migrates deeper into the macOS environment, and see if they start having to have some installer privilege escalation or some other bypass to further lock these things down and restrict it to App Store only files type thing.
In terms of like remediating this sort of thing, is it?
Oh, okay, thanks.
Sorry. So in terms of like remediating this sort of thing and potentially identifying packages that are tampered with, is it basically checksums of files that Blue Team would have to deal with, or do you have other recommendations?
Yeah, so there are signature checks. So if we go all the way back to suspicious package, you can see that, or package util actually has a -- check signature or signature - check, and then you give the package file, and it'll check what it does. But so you can see that this was signed by, there's the command line ways to look at it. So you can check to see, is this signed by the company, the developer that I expect it to be, and then either they did something bad or malicious, intentionally, accidentally, or it's been tampered with. If it's signed, even if it's got a valid signature, but it's not signed by the developer you're expecting, that would throw up a flag for me. So the Praetorian people had a valid signature, but I don't expect my video conferencing file to come from Praetorian. If I did, I'm just asking for trouble. But then there's also, then for most of these, they're not, I don't have to tamper with the package. The package comes pre-vulnerable. And so it's more of like the protections as a developer is to do those checks. Check to see that when you go to do this, a lot of these, they try to write a file, but I already wrote that file, and so it fails. But they don't check the result of their directory create or their file create, and so it just continues on. Those commands fail, but since they're sort of in a batch mode inside this installer script, the installer happily continues through failures until if the last command fails, then the script fails. But as long as there's more commands to run, it's whatever the last exit code was and determines whether it was a success or failure. So you can do those checks, capture the return result of make dir, or before you go use a file, check that it is the user you expect to own it. And then that at the very least, only that user could be attacking you in this and not just any system or process on there pre-wrote that file. Way in the back.
Is there any logging of these failures?
Audit D might be capturing those, it sounds like now, that there might be, but when trying to build my own package and debug why I was failing, I was having a very hard time finding a place, and I had to do a whole bunch of touch and output to temp directories after every single command, so I know where I got to within my script, because I couldn't find a place like in the console logs or anything that was showing me that. I am at 0 minutes left on my time, supposedly, but actually I think I have 5 more minutes. I've short-sheeted myself.
There is time.
That's 5 minutes of applause, people. Thank you.